After finishing off vectors, we're going to move on to motion and force. Okay, and in motion and force, we've got displacement, velocity, and acceleration. You need to know the definitions and the graphs against time. Displacement time graph, velocity time graph, acceleration time graph. You need to know about the gradient of displacement time graph representing velocity, the gradient of velocity time graph representing acceleration, area under the velocity time graph representing distance. And yeah, that's the case. You also need to know about the different types of velocities, like average velocity, which is the total displacement over total time, average speed, total distance over total time. You need to know the difference between distance and displacement, the difference between speed and velocity. You also need to know about acceleration. Acceleration, if it's constant, then what it's called. If it's zero, then what's the motion called. And if it is not constant, if it's changing, then what is that motion called? Well, basically, uniform motion, uniformly accelerated motion, and variable motion. You need to know all three of them. Then you need to know all the equations of uniformly accelerated motion. The SUAT, or some people call it SUAT, but some people call it just the equation of motion. Vv equals to u plus at, s equals to ut plus half at squared, v squared equals u squared plus 2as, and the fourth one, s equals v plus u over 2 times t. So you need to know all of that stuff as well. You also need to know about the case of a ball being thrown upwards, reaches the maximum, reaches there, stays there for a while, and then it returns back to the ground. You need to know about that as well. That's actually a very frequently tested case. They usually give either a person is throwing ball up and it's returning back to his hand, or it's just staying there, like it's just one-way motion needs to be determined, or a person is throwing a rock up from a cliff and then it's falling down into the sea. It's gonna go up and then gonna cross the person and fall down into the sea. These situations are very frequently tested. You need to know this, and you need to know how to apply all these equations of motion on them and when to apply them. They are only applied when the acceleration is constant, otherwise they are not applied. Okay, then you also need to know about all three laws of motion, Newton's laws of motion. You also need to, first law, second law, third law. First law is the law of inertia. You need to know that name as well. Then second law is called is the definition of force. Rate of change of momentum equals force. You need to know that as well. And second law is force equals mass times acceleration as well. You need to know both the equations, both the formulas. And then the third law as well, which is every action has an equal and opposite reaction. Now you also need to know about an important fact, that you need to identify the third law pair forces. If they've given you two pair forces in different statements, you need to identify which of these forces or which of these pairs represent Newton third law pair forces. Okay, how will you do that? On and by, just replace these two words, just switch them, meaning force by A on B or force by B on A. Simple. I just switched B by and on. Two statements would be given and you need to identify which set of statements represent Newton's third law. Then coming to momentum, you need to know about linear momentum. You need to know about the second law relating to momentum, which is rate of change of momentum equals force, and its derivation to F equals ma. You also need to know about impulse, which is the change in momentum, law of conservation of momentum, which is total momentum before and after collision must be equal, elastic and inelastic collisions as well. Elastic collision has no change in kinetic energy, but the inelastic one does. You also need to know about different cases in which are elastic or inelastic. For example, if balls are they collide and they start moving together, they're stuck together, it's inelastic. If it's a ping pong ball is thrown to the wall, it returns back to the same speed, that's elastic. Right? You need to know about all of these cases which are given over here. Okay, there's a kinetic energy formula, I remember. Speed of approach, speed of separation. Elastic collision formula, you don't really need that. You may remember that, of course, but it's not really tested very frequently. What happens when a light body collides with a massive body? What happens when a massive body collides with a stationary body? Like, you don't really need to remember all of these cases, but you should be able to apply law of conservation of momentum on them and decide on your own what to do in each situation. And then the example questions, example 3.4, example 3.5, all the different examples which are given over here, every single example should be known except for the example which requires a calculator, because calculators are not allowed. So You should be able to solve every single question without a calculator. Then force due to water flow. That's also related to momentum, and that also has a specific formula, volume change, right? How to calculate the change in volume of the water through the pipe multiplied by the distance or the speed, stuff like that, right? You need to know about that change in volume, and density is given, volume is given, so you can calculate the mass actually. The pipe formula or the pipe situation is usually about the, it's also to calculate the force which the water applies on a particular area, but that's actually by finding out the change in mass per, like change in momentum can be because of two things, right? Either change in mass or change in velocity per unit time. So if in this situation, because water is flowing out and velocity is constant, so it's the change in mass that's causing the force. You should also know about explosions and apply Newton's, not Newton, apply law of conservation of momentum on explosions. You also should know about projectile motion and all the formulas of projectile motion, including the fact that there are two motions, vertical and horizontal motion. You should know that in the horizontal motion, acceleration is 0. Vertical motion acceleration is the same as acceleration of free fall, which is 9.81. You also should know about the fact that the vertical motion is exactly the same as the ball being thrown upwards and it returns back to the ground. Okay. Horizontal motion is just uniform motion. Horizontal component of velocity remains constant because we assume that the motion, this projectile motion has been taking place under zero air resistance. Okay. Horizontal component of velocity remains constant. You also should know the fact that at the maximum peak of the projectile, the kinetic energy is not zero because it still has horizontal component of velocity. You should know the formula of height of projectile and the range of projectile, and at what angle is the height equal to, or the range equal to 5 times the height. You should know that as well. You should know the time of flight formula, range of projectile formula, and height of projectile formula, and at what angle is the range maximum. So that's it for this chapter, forces and motion. Next would be work and energy. We'll meet you in the next video.